Okay, so this could have been yesterday's example. Same kind of stuff. Let's just quickly kind of review what we need to do here. I got to graph this. If I didn't have an inequality, if that was an equal sign, that's a grade 10 pre-calc foundations question. Okay? What do I need to do? Well, first I need to find that line. Okay? What is that line? So I just treat this thing like it was linear, a line, no inequality. And how many points do I need to do a line? 2. What 2 points do I want to get? X-intercept, Y-intercept in stereo. Okay, so do this. Don't just, write this down. Okay? X-intercept, Y is 0. Because some of us, we get to the bottom doing some algebra and we get some number and then I'll say, okay, what is that? I don't know. Okay? This is our thought process. When we get to the bottom, I found the x-intercept. Okay? And then I can find the coordinate because I know what the x-intercept, y is 0. Okay? Substitute it in. Minus 2x plus 0 is 2. So minus 2x is 2. I want x. Divide by negative 2. 2 divided by negative 2 is negative 1. What was I doing again? Well, look back here. That's the x-intercept. The coordinates of that are negative 1 and 0. Okay, right there. 1 point down, 1 to go. At the y-intercept, what happens? X is 0. And this one's usually easier, but sometimes not. Okay? So if x is 0, I got negative 2 times 0 plus y. I want to make this equal to, okay, I just want the line here, not worried about what part I'm shading. 0 plus y is 2. Y is 2. Okay, what's the coordinate? Well, this is a y-intercept. I know x is 0. So that's 0, 1, 2. There's my other point. Next thing we need to determine, do I want to make this a solid line or a dashed line? You agree, Megan? With the one who is right? Ooh, dashed, solid. Tristan? Ah, it's equal solid line. Okay? Solid. If I have that equal part in there, this line is part of the solution. It can be on the line because it's equal. If it's just less than or greater than, this line is not the solution. It's either greater than it or just less than it, not equal to this line. Okay, so I'm making that solid. Then what? This is the Math 11 part. I'm going to shade one side of this line. What side do I shade? I don't know. I want to test a point and see if it works in this equation. The nicest one is 0, 0. Okay, if you can clearly see that's on one side of this line, that's probably the one you want to use. Okay, 0, 0. Let's see what happens. Negative 2 times 0 plus y is 0. Is that greater than or equal to 2? Is 0 greater than or equal to 2? Definitely not. So that's not part of the solution. I want to shade the other side of the line. That's the solution. Okay? Okay, that's it. Example 2. Three. This one's going to look a little different though. There's not much there. It looks easier. Usually that means it's harder. Okay? Because we don't have quite the same procedures. Algebraically, anyway. Okay? The procedures you want to solve this are exactly the same. What did I do first here? I want to find 2 points on this line so I can draw the line. How do I do that? X-intercept, y is 0. Okay? I want to look at this equation, and you do that and you go, well, huh? What's going on here? Is 0 equal to -2? No. X-intercept doesn't make any sense because there is no X-intercept. Here is the line. Y is -2. Irregardless of X. There's no X even here. Okay? So here's -1. Here's -2 for Y. If X is 0, Y is -2. If X is -4, Y is -2. If X is -8, Y is -2. If X is 2, Y is -2. Do I care what X is? Y is always -2. Okay? That is a horizontal line at the point Y is -2. Was I correct in making it solid? Yes. Okay, because I have this equal, I want to make it a solid line. Okay? If you recall that from grade 10, we did the same thing, and yeah, people got confused then, and well, they're still confused now. Okay? You just got to think, there's no X. I don't care what X is. Y is always -2. Give me any value of X. Y is -2. Okay? We don't care about X. There is no X. It does not cross the X-intercept. So, how many points do I need? 2. But, you know, I got 100 points here. Okay? So that one's a little different. You just got to think. Okay? So that's still Math 10. The Math 11 part, what side do I shade? Can I find my nice happy test point? 0, 0. Plug it in the equation. There is no X, but I can use Y is 0. Is 0 less than or equal to -2? Careful. Would you rather have $0 or -$2? You'd rather have no money than owing $2, right? This isn't true. Was that helpful? Probably not. Okay? Negative is less than 0, right? 0 is not less than -2. 0 is greater than -2. That's not part of the solution area. So that, I'm going to shade the other side. Think of this another way. Just look here. This says the values of Y that are less than or equal to -2. That's all of these, isn't it? -3, yep. -4, yep. -23, yep. This one you might not even need to do a test point. Just look at the equation. The values of Y that are less than or equal to -2. That's all these. Okay? So that's the weird one that is like 5C that I'm going to give you. One more that looks like number 3. Let's call it example 3. Okay, couple of words. We're going to see this for quite a while. Okay, word problems, some equations. So this one is leading us into that. It's important. Bob works 3 times. Are we okay with that? 3 times? let's actually just, you know what, because that looks like 3x, and we're in math, so you think 3x. 3 times as many hours as usual. Jen works twice as many hours as usual. Because it's like, I don't know, Christmas break, and they're not going to school, so they can put in some more time. Okay? Make sense? Okay, there's 40 hours to cover at work, so they together make up that 40 hours. They work less than 40 hours a week together. After. We're going to give you the equation for starters, okay? In a few days, you've got to make the equation. That's what that says. Okay? Does that kind of look like it kind of makes sense? What do B and J stand for? Bob and Jen, what? Their height? Their weight? You're talking about Bob or Jen? Uh-oh. All right. That's called mowing the lawn on both sides of the fence. You're awesome. This B stands for hours that he works, and that's okay, by the way. J stands for how many hours Jen works. Okay, so if Bob normally works, say, 6 hours, but it's Christmas holidays, summer holidays, now he's working 3 times as many, that would be 3 times 6, 18. Okay, 3 times. Twice means double, or 2 times. If she worked 10 hours, now she's working 20. Okay, this place, there's only 40 hours to cover here. Between the two of them, we have to get those 40 hours covered. Okay? So these both have to add up to less than 40. See the less than? You gonna live? Your face is the same color as your shirt. Okay? So that's the equation. What's a question? What are the restrictions on B and J? And you don't even know what that means yet. Okay, but you're going to get this wordage again, so let's figure out what I'm trying to ask you here. Remember back in grade 10 we were doing graphs? We could have numbers that were real. Different color. We could have numbers that were natural. Yeah. Well, yeah, we did that, but that's not what I want here. Okay? So like you work pi hours. Doesn't really fit. Real, natural, or, this is your last choice, whole. Yeah. Every situation you get when you're getting a question like this, you got to think, what makes sense here? What's the difference between real, natural, and whole? Real is like decimals, right? Negatives, fractions. Natural numbers, that's where they started the number system. That's just 1, 2, 3, so on and so on. Okay? Whole numbers include 0. It's just the natural number system and 0. Oh, sorry, we got one more. What about the negatives? Integers, that's like -4, -3, okay, -2, 0, 1. If this was a money question, it'd probably be all real, right? Because you can have $1, owe $2. Could I owe $2.50? Sure, right? In this, I'm talking about hours you work. Can I have -3 hours? Does that make any sense? It doesn't. You can work no hours or 1 hour, 2 hour. Could I work an hour and a half? Yeah, sure. Okay, but to simplify this question, we're not going to use half an hours. Okay, we're going to use whole hours. That's the restrictions on this. Okay, we just want, he's working 1 hour or 2 hours, maybe 10 hours. Maybe he didn't work at all and had 0 hours. Okay, that's the restriction. That's what we're talking about. It's whole numbers only. I can't have 1/10 of an hour. So real, I gotta take away. Natural, yeah, but I could also work no hours. So whole is the best fit here. Integers, I can't work -6 hours. Okay? So that's what we mean by restrictions. Whole numbers only. Okay? So if I'm graphing this quickly, I'm not going to graph it completely, but if these are quadrants, how many quadrants would I use when I'm graphing this if I'm just having whole numbers? Just that. Because this is positive for x here. This is positive for y here. Can I have negative hours? No. Okay, this is negative for both x and y, and that's negative for y, which is maybe money, right? Or the hours of both of them on the same graph. Yeah, I just want one quadrant. Okay, quadrant 1, or you could just say the positive quadrant. That's fine too. Okay, this is the only part of the graph that makes sense here when I'm graphing this. None of the negatives make sense. Okay, that's all we're trying to say. All right. Okay. So you should have done 125AB. If you haven't, do it and add these on there as well. Now we can do all of 5.